Welcome. Today, we're diving into the bulkhead pattern, a crucial design approach in cloud architecture. Inspired by the sectioned hulls of ships, the bulkhead pattern isolates parts of an application into separate pools. This means if one part fails, the rest keep running smoothly. Just like a ship stays afloat even if one compartment is flooded, your application remains resilient against failures. In the world of cloud services, where multiple components interact, this pattern is a game changer for reliability and stability. Let's explore how it works, why it matters, and how you can use it to build robust systems. Bulkhead pattern gets its name from ships. Imagine a ship's hull divided into watertight compartments. If one section is breached, only that part fills with water, preventing the entire ship from sinking. Similarly, in software, bulkheads isolate failures, ensuring that a problem in one area doesn't bring down the whole application. This analogy helps us visualize the importance of separation and containment in system design. By adopting this approach, you can safeguard your application's core functions, even when unexpected issues arise in specific components. Cloud-based applications often rely on multiple services, each serving different consumers. When one service faces excessive load or fails, it can impact all its consumers. For example, if a client keeps sending requests to a misconfigured or unresponsive service, resources like connection pools can get exhausted. This not only affects the problematic service, but can also prevent the client from accessing other services. Such cascading failures can cripple your application, making it essential to find ways to contain and manage these risks. Resource exhaustion is a common issue in distributed systems. When a client or service uses up all available resources, like threads or connections, other parts of the application can't function properly. This often leads to a domino effect, where one failure triggers others. For instance, if a single client overwhelms a service, other clients may lose access, causing widespread disruption. Bulkhead pattern addresses this by isolating resources, so one failure doesn't drain everything else. Core solution of the bulkhead pattern is partitioning. By dividing service instances into groups based on consumer load and availability needs, you can isolate failures. For example, a consumer calling multiple services can have a separate connection pool for each. If one service fails, only its pool is affected, allowing the consumer to keep using other services. This approach ensures that issues remain contained and don't escalate into larger outages. Implementing the bulkhead pattern brings several key benefits. First, it isolates consumers and services from cascading failures, so a problem in one area doesn't affect the whole system. Second, it preserves functionality during service failures. Other parts of your application keep working. Third, it allows you to offer different quality of service levels, such as prioritizing critical consumers. These advantages make the bulkhead pattern a powerful tool for building resilient, flexible applications. Let's look at a visual example. Imagine 3 services, A, B, and C, each with its own connection pool. If service A fails, only the workloads using its pool are affected. Services B and C continue operating without interruption. This clear separation ensures that a single failure doesn't ripple through your entire application, keeping most of your services available to users. Here's another scenario. Multiple clients call a single service, but each client is assigned a separate service instance. If one client overwhelms its instance, the others remain unaffected. This isolation allows the rest of the clients to continue making calls, demonstrating how the bulkhead pattern protects against overloads and keeps your system responsive. In implementing the bulkhead pattern, it's important to define partitions based on your business and technical needs. If you're using domain-driven design for microservices, align partition boundaries with bounded contexts. Also, consider the level of isolation your technology provides and weigh the overhead in terms of cost, performance, and manageability. Combining bulkheads with other patterns like circuit breaker and throttling can further enhance your system's resilience. Partition consumers, you can use processes, thread pools, or semaphores. Frameworks like Resilience4j and Poly make it easier to create consumer bulkheads. For services, consider deploying them in separate virtual machines, containers, or processes. Containers, in particular, offer a good balance between resource isolation and overhead. For asynchronous communication, use separate queues for each service or consumer group, ensuring that message processing remains isolated. Determining the right level of granularity for your bulkheads is crucial. You might choose to isolate each tenant in a separate partition or group several tenants together. Regardless of your approach, it's essential to monitor each partition's performance and service level agreements. This ongoing oversight helps you quickly detect and address issues, ensuring your application remains reliable and efficient. Bulkhead pattern is ideal when you need to isolate resources for backend services, especially if your application can still function when one service is down. It's also useful for separating critical consumers from standard ones and protecting your application from cascading failures. However, If your project can't tolerate less efficient resource use or added complexity, this pattern might not be the best fit. Bulkhead pattern supports several pillars of the Azure well-architected framework. For reliability, it helps your workload recover from failures by containing faults within isolated segments. For security, segmentation limits the impact of security incidents. For performance efficiency, each bulkhead can be scaled individually to meet specific demands. Always consider trade-offs with other design goals when implementing this pattern. Let's look at a practical example. In Kubernetes, you can create an isolated container for a service, specifying its own CPU and memory resources. This ensures that each service runs independently, with clear resource boundaries. If one container experiences issues, others remain unaffected, perfectly illustrating the bulkhead pattern in action within a modern cloud environment. Summary: the bulkhead pattern is a powerful strategy for building resilient, reliable cloud applications. By isolating components and resources, you protect your system from cascading failures and maintain service availability. Consider combining this pattern with others like Circuit Breaker and Retry for even greater fault tolerance. As you design your next cloud solution, think about how the bulkhead pattern can help you achieve your reliability and performance goals.